Hey guys, Matt Marzillo here. In this video, we're going to be going over an example of how to use the PMT or the payment function of Microsoft Excel. Make sure that before you watch this video, you've checked out the video that covers the definitions of all the arguments that are used in the two financial functions that we're going to be covering. Okay, so what we have here is an example of buying a car. So we have a car loan, and we have a certain number of assumptions here that we're taking out a loan for $20,000. So let's assume we're taking out a loan for the entire value of the vehicle. That's $20,000. We have an interest rate here. This is an annual interest rate of 5%. And we also have a term of 5 years, right? So we're going to be paying this down over the course of 5 years or 60 months. What we want to discover is what the monthly payment is going to look like. And we're going to use the payment function, and I've put the syntax right here in column C just for your reference. But what we're going to do is rather than type in the actual function, we're going to use this formula wizard that Excel offers. So I'm going to highlight the cell, and I'm going to go up top here to this little FX sign where it says insert function. I'm going to click on that. And what you can do is you can use this search bar here to search for your functions. You can see the PMT functions right there, but it probably isn't on your machine since you haven't used it. So you're going to click on all instead of most recently used, and then you would search PMT from there, and that should be the easiest way for you to find it. Click go, and there PMT pops right up there. So okay, double click on PMT. And Excel gives us this nice little function wizard or formula wizard, so to speak. And it kind of gives you what arguments are specifically required, and we can work from it from here, a little more intuitive that way. So rate, so we're trying to calculate, it's important to remember, we're trying to calculate the monthly payment as opposed to the annual payment. So we want to make sure that we're converting everything to months. So we can click on cell B4 here, that's our annual rate. But we want to make sure we divide that by 12 to give us the monthly rate, right? For the NPER, that's the number of periods. We have 5 here, but that's the number of years. So we also want to make sure that we multiply that by 12 because we're looking at months. So we want to see 60 months. Great. PV, that's the present value, right? So that's the starting point. That's the $20,000 of principal here in cell B3. We'll click on that. The future value is 0. It's always going to be 0 for loans most of the time, right? You're paying a loan off to get to 0. In type, we're just going to leave blank. We're not going to worry about that here. So you can see Excel already calculates it out for you, saying $377.42 is the monthly payment based on these the values of these arguments. So click OK. And Excel puts in a negative number here, $377.42, right? Because technically making a payment is a negative number since you're paying down the principal. But if you want to make that a positive number, I would suggest using the absolute function in Microsoft Excel. So highlight the cell and go up to the formula bar and click right after the equal sign, and you would type absolute, or I'm sorry, you would type ABS for absolute, open the parentheses around the function, around the payment function. So we're doubling up functions here. Hit enter. So if you see how that looks, right? So we have ABS, parentheses, and the payment function that we just created using the wizard, right? Ends with that red paren. And then we close up our absolute function with that second black paren right there. Click enter. And you can see it just gives us a positive number. So absolute, means you're essentially just taking all the negatives, making it positive. Positive remains positive. Okay, so this is great. So we know if we're taking out if we're buying a $20,000 car, we're taking a loan on the full amount of the vehicle at a 5% rate over 5 years. We're going to be paying $377.42 a month. And the cool thing about this is that if you set it up while you're referencing the actual cell values, you can change the cell values and see how your monthly payment's going to be affected, right? So say you want to stretch it out to 6 years and see how that affects your payment. Okay, it takes you down $50, so maybe that might help. If you're okay with having the loan for next year and having the car payment for next year, that extra $50 a month might help. Let's bring it back to 5. Or let's say you're really trying to you have good credit and your bank's offering you a 5% interest rate, but you know you could do better, and you want to push them and see if you can get them down to 3%. So you change it to 3%. Okay, that takes you down from $377 to $359. That's another $17, $18 a month. That's not bad. Maybe it's worth kind of trying to negotiate with your bank a little bit. So right when you set up the cell referencing, it allows you to kind of toggle around with the different values in the cells and kind of see how this monthly payment number changes. Okay, so that's that. Down at the bottom here, this yellow table we have down here, we have what we're calling an amortization chart, right? So we have all 60 periods listed on the left in column A here. So you see 1 through 60 should be. Yep, okay. So that's saying, what each payment's going to look like. And we're trying to understand how the interest paid changes over the life of the loan. Something many of you might know, or some of you might know, is that earlier in the loan you're paying a lot in interest, but later on in the loan you're not, right? You're paying mostly principal, and this table will sort of lay that out for you really clearly. So the first thing we want to understand is that we're starting with a balance of $20,000, right? That's our present value, and the interest on that is going to be the monthly interest rate multiplied by the balance. So we're going to do a simple formula here. I'm going to go equals B4 divided by 12, right, since it's monthly, and then we're going to multiply that by the balance. Okay, so in the first payment, we're paying $83.33 in interest, right? So we're going to cut a check to the bank or to the car dealership, whoever floated us the loan, for $377, and $83.33 is going to go to interest, which is, it kind of hurts to see that, But then we want to see, okay, how much of that is actually going to be applied to the principal. So that's simply by taking the monthly payment and subtracting the interest paid, right? The difference there. Okay, so we are contributing $295 to the principal paid. So that helps, right? And now we want to calculate the new balance, and we simply take $20,000 here and subtract the amount applied to principal. Okay, so now that we have this set up, we want to make sure we do one thing before we start pulling down formula. Right? So we're going to pull down all these formulas to populate this chart, but I want to include an absolute cell reference for cell B4, right? Because that's going to stay the same. We're always going to want to make sure we're pulling the same interest rate. So let's put a $sign before the B, a $sign before the 4, right? We want that to change. Okay, that's good there. B7 minus B14. So we want that B7 to stay the same, right? We want, because the monthly payment's going to be the same every month. So B7 minus B14. And then this stays the same. Okay, so we have this set up appropriately, right? So we have an absolute cell reference here to B4. So that's going to stay the same when I pull it down. We have an absolute reference here to cell B7, so that stays the same even when I pull it down. And then the balance will change. Okay, very good. Let's highlight all three of these cells. Let's grab that button and let's pull it down. Okay, great. And you can see here, as I said, towards the end of the loan, you're paying off very little interest, right? So, most folks, and I'm sure your parents will tell you, try to overpay on your loans if you can, right? So I would definitely recommend that, but I would say, it's probably more important to overpay early on in the loan, because the sooner you can pay down the principal, the faster this interest paid on a monthly basis goes down, right? Because overpaying later on in the loan, you're really not paying that much interest anyway. So if you needed that money for something else, save it for something else. Another cool thing about this chart too is that you can, if you manually change the monthly payment. So say you are going to start overpaying. Say, you know what? I'm going to round that up. I'm just going to manually change this to $400. I have the extra money in my pocket. Let's just type in 400, and we can see how that changes. right? So the interest paid has essentially gone down every month. If you look in column D, you'll see that we actually paid off right here after the 56th term, right? We're only sitting at $73 after month 56. We'll just pay that off and then we're done. I mean, by paying an extra $23 every month, we essentially eliminate these last 4 payments plus this payment right here really isn't much, only $73. So that's a nice way to kind of understand how overpaying will help eliminate the loan a little bit faster. Okay, one other thing I'll mention really quick here before I cut out is that I did use a function here that calculates the cumulative interest payment amount. Just kind of show you what I used there. There's really we're not going to be using it. It's not going to be on the homework, not going to be on the test. But if you are kind of looking to fiddle around, that's the formula or the function that we're using here to calculate the cumulative interest payment. Okay, guys, that's it for me. We'll have one more payment function example and then another future value example, and that'll be it for the week. Have any questions, feel free to give me an email shoot me an email or give me a call. Thanks a lot.